right, so the warm-ups that we're going to do on this sheet that you have, we'll do that at the end. It says at the beginning, but I just want to review the graphical part of this chapter a little bit. It's not a huge thing we hit, but it's a couple points on the test, and we haven't talked about it for a while, so I'll hit those warm-ups at the end. First thing I want to tell you is that we have lots of stuff out there, so I want to make sure you know what's due when and what's optional and all that good stuff. So nothing's due today, right? Nothing's due tomorrow. Tomorrow you'll take it's just one sheet, so you'll have the rest of the day tomorrow to work, depending on how long it takes you to do that sheet. The sheet has 2 FRQs on it, and then, two related rates, and 1 FRQ directly out of that packet. So as far as the related rates go, they're nothing out of the ordinary. So if you were good at them on your problem set, and if you were good at them in the bookwork, and if you've got them down, they should flow nicely. If you don't, the most common kind I have your back on, so I'll show you that in a little bit. But tomorrow, two related rates, and there's 4 different forms, so you don't know what you're going to get. And I think I told you that yesterday. You might have the ladder and the shadow, you might have the cone and an airplane or something. 4 different sheets, and then 1 FRQ directly off that sheet from yesterday. If those went well and you got them all right, I wouldn't look at it again. If number 3 was rough, I'd look at 3. You know what I mean? So you guys, I kind of leave how much you study up to you, but I make sure everything's out there beforehand because of the retake thing. So speaking of that, this test, it's actually not test corrections that you're eligible for, because if you don't do well, it's the same 8 questions every year that wouldn't go well for you. So there are some that pretty much everybody gets right, like where's the critical values on this function? Or there's some that are just, everyone's going to get them right. So the option for fixing your test this chapter is I give you 8 multiple choice questions that are like the hardest 8 on the test, and you get 1% back for each one of those you get right. So it's sort of a retake, but on the 8 biggest topics, and that gets done in an ELK time after break. So it's a little different this time, but to be eligible, just to repeat the checklist, the study guide's been out there. This is actually, making that study guide is super important, because the math on this test is easy. What did I just say? The math is easy. It's just knowing what to do when. So for example, if the first question says find the absolute extrema, and you make a sign line, that's not how we find absolute extrema. Correct? Somebody who's made the study guide probably has sorted that out already. What do you do for absolute extrema? You make a table. Who goes on it? The endpoints and the critical values, and then the math is easy. You just take derivative and plug stuff in. The math is easy, but there's a really big there's the chance of mixing stuff up. So there's a chance where it's going to ask you maybe to find relative min, and you do the test for absolute. So you just have to make sure you have the processes down, and the study guide really helps that. My person who was done with the study guide last hour, somebody who sits right here, just cruised through this, and she said it was easy, because she'd already made the study guide, and so she basically finished it. The second thing is, the first day of the chapter, I gave out that chapter review packet. That's a little harder than how you're tested. So if that's going well, your test is going to go well. The FRQs we did yesterday, right? And then this is the last thing. This is totally optional. I'm going to pass this out. If you're in 6th hour listening to this video, this is the sheet I gave you guys yesterday, but there's one fix I'll need you guys to do as well. So this optional review, you don't have to do it, and if you've got this chapter down, whoops, I feel like I'm missing some. Here's another one. That's strange. I might have to go make some more copies. All right. I'll do that later, unless I have some more up here. Let me just check. Oh, I do. There they are. Ha! All right. So first of all, you can cross off number 4. And I told 6th hour, I told you guys that yesterday. If you're in 6th hour and you weren't here yesterday, you should probably walk to my room and pick one up off the front desk. So number 4, you don't have to do. I won't test you on Rolle's theorem. Do you guys know why? It's really the MVT. I will test you on the MVT. Rolle's is It basically is the same thing. So you can cross off number 4. You can cross off number 6. I love the problem. I got this off the internet and I really like it. But number 6, we didn't do. I really like the problem. If you need an enrichment question, do 6, but you can cross it off if you want. On the back, and this is 6th hour if you're listening to this, number 10, I need to have you change the interval. So on number 10, I want you to do the closed interval from 5 to 9, because that's how it is on the key. So number 10, verifying that the mean value theorem can be applied, and then change the interval to 5, 9. All right, are we good with that? So if it were me, I would maybe work on the related rates parts of things today, because that's what's being tested tomorrow, but it doesn't really matter. If you need any extra study before I leave this screen, because I always like, I don't make everybody do everything because some people don't need to, but in the folder I kind of have your back on the big stuff that people tend to screw up. In the bottom of this, there we go. The last few things in this folder are not required, they're not extra credit, but last hour somebody asked me on a related rate with the cone, and I said it's just like this video right here. I do the 2 different kinds in this video. So I do the kind where you need the product rule and the kind when you don't. If you don't know the difference between those 2, I just quickly watch this. Does that make sense? You know how sometimes you do the 1/3 pi r squared h and you launch into the product rule, and then sometimes you write like h is half of r and you don't use the product rule? If you know the difference, don't watch the videos. If you're sitting there going, I always screw those up, then watch them. So I have that in there because that's a big thing people miss. And what else did I put in there? I put the second derivative test in there because that's also something people miss. So there's the second derivative test. I have a little video as well. The key to the optional review is in there. It's fully worked out. Here, I'll show you. It's like not just answers, it's me explaining pretty much everything I do on there. If you haven't started the study guide, what some people were choosing to do last hour is use these as their examples on the study guide. That way they kind of killed off 2 things at once. Does that make sense? You know what I'm talking about? So like the first question is about absolute extrema. So when they wrote about absolute extrema on the study guide, this is the example they chose so that they kind of did it at the same time. And then they wrote for number 1 on here, they wrote did on my study guide. And I'm fine with that. You don't need to do it twice. So if you want to choose these as your samples, that's good. All right, so that's it. The only thing I'm going to discuss with you before you get a work day is graphing, because it's been a while. I'm a little worried about that we haven't talked about the mean value theorem for a while, and we haven't talked about the graphs for a while. But the mean value theorem's in your review stuff a lot. This is not. So take this sheet out, 6th hour. You don't have this sheet, but you should watch and listen if you're watching this video. This says if you're given the graph of f of x, and you're going to write this, it isn't calculus. So you won't be given the graph of f of x. You've got to be very careful that you will actually in this class never read a graph at what I call face value. For example, Sean, I would never give you the graph of f and ask you where it's concave down, because that's not calculus. It's right concave down right here. I can see it. It's concave down right here. I can see it. I'd never ask you for the relative maxes and mins right here, right here, right here. I would never ask you where this function's increasing because you can see it. This is, if you're taking it at face value, you're probably doing it wrong. Does that make sense? Because I won't give you the graph of f. This will not happen. You will be given the graph of f prime. So go ahead and write that. Understand that this is the same graph I had up above, but this is not the graph of f. This is the graph of f prime. For some people, it helps them to make a sign line in this scenario. So if that helps you, you might want to pretend that it wasn't a graph and that you went and did some algebra and you found that at -3 there was a 0, and at 0 there was a 0, and at 4 there was a 0. Right? And maybe you found the derivatives from, like, this is negative over here, and then we're positive, we're still positive, and then we're negative. If you like to read the sign lines, make a sign line. Does that make sense? Now, it said, where did f have a relative max? If you tell me at -2 and at 2, you're reading it at face value, and we never read it at face. I won't ask you for the relative max if you can see it. Does that make sense? So it's the graph of f prime, and you have to think of what that graph has to do. At a relative max, what does f prime have to do? Change sign from what to what? Positive to negative. So we have to look at where our y values, because that's what's being graphed, change from positive to negative. If you do it off the graph, where are my y values changing from positive to negative? At 4. This would be the location of a max. If you chose to make the sign line, you can see right here as well. So it's up to you which you choose, but this would be at x equals 4. You do not read these graphs at face value unless they're the graph of f, and I just told you, Lodemeyer, I'm not going to give you that. That's pre-calc. Okay, next step. Where is f concave up? Do not read it at face value and say, oh, it's right here where it's holding water. That's not what this is. This is the graph of f prime, so this is a hard question. You have to think of what f prime has to do. So let's talk about it. Concavity is determined by f double prime. Concave up means f double has to be positive. So what does f prime have to do? It's a hard question. The math is easy. That's what this whole test is. Easy math. Difficult concepts. What does f prime have to do? What do you think? In order for its derivative to be positive. I heard it. What'd you say? It needs to be increasing. Yes, for this guy's derivative to be positive, right, it must be increasing. If a function is increasing, its slopes or its derivative is positive. Excellent, Lodemeyer. So you'd be looking where this is increasing. The math is easy, but the thought process is kind of hard, right? Lodemeyer, good job. So we would be looking on this interval, right, let's just end these. Let's pretend they're not arrows. So -4 to -2 union 0 to 2. And here's why. Remember, this is the graph of f prime. The slope right here would be the derivative, f double, and it is positive. So the original function must have been concave up. There's a ton of this in our next unit and just a tiny bit on your test on Thursday. But I want to make sure I want to make sure I've talked about it enough. So let's go to the next one. And then we're done. What if it's the graph of f double prime? Notice it's the same graph again, but now this is actually graphing all second derivatives. What this means is the second derivative at -2 was 3. Does that make sense? Watch. What this dot right here represents is that f double prime at -2 is equal to 3. There was a positive second derivative. So guess what? Even though this looks concave down, and it is, what was f there? Concave up. Do you get why? So let's go read this. It says, where is f concave up? Well, concavity is determined by a second derivative. We need it to be positive, and that's what's being graphed. So basically, I need my y's to be positive. Where do I look on the graph? Above the x-axis. If that's easy for you, next chapter is going to be a breeze because there's a lot of that. If it's hard for you, it's really not, it's got to click at some point. It'll affect like 2 questions on your test on Thursday, but just to make sure you understand what's being graphed. My y values are my second derivative. Concave up needs to be positive, so my y's need to be positive. It would be that interval. So you'd say -3 to 4, or I told you College Board also accepts -3 to 0, union 0 to 4, but prefers this one. I'll accept either as well. I'll keep it consistent. So if you like to split it there, that's fine. The next question, and the last one before you get to work. Where is f prime decreasing? So take a look. We're looking at the second derivative. So here's f prime, right? A function is decreasing when its derivative is what? Negative. So I need my y values to be negative. So where do I look? Below the x-axis. It's tricky thought, but easy math. I mean, I don't know that I'm really working with math. I'm thinking conceptually. But right here, so that'd be -4, -3, union, let's say 4 to, let's end that 5. So you got to be a little careful with these graphs. But there aren't a whole lot on this test. It won't make or break. It'd be the difference between a A- and a B+ at most. But I feel like I haven't talked about that for like a week. So we are done.